All right. Hello and welcome to week 16. Couple of announcements. Number one, the week 16 exam it's hard to describe. It's not actually mandatory, highly recommended, but because we're so close to the end of the year, there's not an online version and there's not really time to do a retake or a makeup. So if the week 16 exam hurts your grade, if it brings it down, I will excuse it and not count it. And if you get 50% or higher on the week 16 exam, you come in person and do that. Then you get 50 extra credit homework points. Okay, so the week 16 exam, not mandatory, but highly recommended. This material will also show up on the final. So if you don't take the week 16 exam, the final will be the first time you will have tested on the material, which is not ideal. Tomorrow is perfect. Yes. And if you get 50% or higher, excuse me, you get 50 extra credit homework points. The final exam, there is an online and an in-person. The online does not have a max grade, but you just want to come take the in-person. The in-person, it's like 35 multiple choice and 7 free response questions. And yeah, it's not the hardest concepts. Anything from the whole semester is fair game, but it's not harder. So we're going to do a little reviewing, getting ready for it. And then here's the schedule. For advanced algebra, the final, I could be writing this. Okay. Oh, okay, look at this. Can you believe I use? Is that the one you use to stand it up? It is, and it's like old, dried up remnant of COVID, but it is the perfect little stand thing. So it's kind of funny. Okay, so final exam, which is especially important if you are in chemistry, because I want you to do mine before chem. Okay, so the final exam scheduled for Friday, May 17th. Okay. If you cannot come that day, no finals on the 20th. You can also take it on Tuesday, May 21st. Okay. And it is full credit until the Friday of that week. But get in here, get it over with. So you want to take it before it's full credit until the 24th. And then it's going to start to lose points. No. Okay. So Monday, the 20th, I will probably be here in the afternoon, but I can't promise. Okay. I have to take my daughter to something in the morning and I should be here by the afternoon. So not sure about Monday, the 20th. Okay. Tuesday is a safer bet, or Friday. Okay. And definitely let me know when you plan on coming in. All right, let's get started. Now, solve the equation for blah, 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 weird stuff, right? Oh, so you're going to be a field trip. Oh, for CTech. You have a field trip on Monday, or okay, anyway, we can talk about it on the 20 on Tuesday. Do you want to take it Wednesday? You want to take it Thursday, Friday? I don't care. I'm trying to schedule it around chemistry. So, you could take it early. Yeah. Okay, let's get going. Now, solve the equation. So this is talking about, it's a hint that I want degrees. Now, in future math classes, you are no. It's gonna electrocute me. I don't think we're gonna have a projector today. So go ahead and grab a Chromebook. Oh, it came out and got stepped on. Yeah, there's no way I'm gonna be able to put this together. Wow. See, yeah. Okay, and I didn't check that sooner. So I'll have to get a new cord. Okay. Sorry about that. Just found out my projector cord is not working. So okay, so we're all gonna have to sign in. Okay, so meanwhile, no. Okay, I'm gonna get going. Now I want to know where cosine of what angle is going to give me -1/2. So these are the angles, and we remember cosine looks like this, right? Cosine starts high, doesn't start in the middle, starts high. So it starts high. Oh, yay. Kevin's in. Okay. Now, we usually only do one cycle of cosine, but it keeps going forever. Cosine, in fact, I was just listening to a podcast. Yeah, I listened to math teacher podcasts talking about it. She was just talking about trig this morning on my way to work. Such a geek. But anyway, just talking about, okay, so let's say examples of things that are periodic. Okay, like this, like temperature. Yay. Temperature in the morning, it goes up, in the evening, it goes down. Okay. The sun, and it goes up and down and up and down. They actually go forever. Okay. A cosine curve actually goes forever. So here is -1. I want to know what angle cosine is -1/2. So it's here, it's here, it's here, it's here, it's here. And if you were to photo math this, you would get the answer plus K pi or plus K 180 degrees. But I only want the first answer. Okay, we're not going to solve these in degrees unless we're using a table. If we're using a calculator, we are going to solve these in degrees, not radians. And I want the first answer. And yay, you're in. Okay, so are you ready? I've made it sound like it's really complicated. Easy peasy. Yeah, how do I solve this equation? Super easy. Don't worry about the graph. Don't worry about anything. What do I do? Okay, we're going to convert the fraction to a decimal. You actually don't have to. You could just type it in as -1/2. Now, I'm not doing cosine of -1/2. I'm doing up, ding, ding, ding. I see that inverse. Excuse me, inverse cosine of -1/2 is equal to theta. So theta is equal to, since it's negative 120 degrees. Now, you're not, if you photo math, it's going to say plus K pi plus K 180. We're not doing that.
I used to calculate it. You told me on the website, but it was giving me like weird things.
Oh, we'll have to play around with that.
Yeah.
We'll have to look at that. Okay, we'll find a better calculator for you. Or it may have been in radians. So maybe we need to use that calculator, but have it in degrees. We are doing these problems in degrees. Okay, so we're just going to find the inverse. Now we could look at this and look at the table. If I could find the table. Okay, so this next one is asking, where is sine square root 2/2? Yeah, do you see what degrees sine? Now we can only use the table if it's positive. Where is, so sine of theta is square root 2/2. Can you tell me what theta is?
45.
Ding, ding, ding. Sine square root 2/2, the answer is 45. Now let's try it with the calculator. Okay, so I want to do, and you could do it in 2 steps. You could convert this to a decimal, or you could do it all in 1 step. Let's convert this to a decimal. So square root 2 divided by 2 is what as a decimal? Okay, did we get 0.707? Okay, so now we're going to do inverse sine of 0.70710678. So inverse sine, I don't like to type them in. I just go second answer. And we get theta is equal to 45 degrees. Now, if you want to skip a step, you could just do inverse sine of square root 2 divided by 2 equals, and it will also give you 45 degrees. Okay, we're going to keep moving. Number 3, before I do the inverse sine, what should I do? Okay, so I'm going to isolate the variable. I'm going to add 2 to both sides. Oh, look at that. Oh, can I move it? Right there. Okay. Okay. What? Why did? Okay, maybe not. Make that one go away. Okay, sorry. Talking to myself. Okay, so I'm going to add, so this is 0 sine theta equals 0. I could look at the table and it would help me understand the process of what we're doing. So now we're just going to go inverse sine of 0 equals what? 0. Okay, I think we're good on that one. 30, 60, 90 triangle. This is called the what? Long leg. This is the short leg, and this is the hypotenuse. So how do I go from long leg to short leg using the multiply divide shortcut? Okay, square root 3 divided by square root 3. Oh, yay. I love when the long leg, there we go. Thank you. I love when the long leg has a square root 3 in it. Equals 1. Okay, now short leg to hypotenuse. Okay, and numbers getting bigger. I am multiplying by 2. So A equals 2. Okay, I love when the long leg has a square root 3 in it. Oh no, look at number 5. What if the long leg does not have a square root 3? Oh, woe is me. Yeah. Okay, how do I go from, this is the long leg. Let's label. This is the short leg, and this is the hypotenuse. I see extra work coming because my long leg is given and it does not have a square root 3. So to go from long leg to short leg, I divide by square root 3. Ah, yes. So 5 divided by square root 3. Uh-oh. No radicals in the basement. Okay, I cannot leave that. So I have to multiply by square root 3 over square root 3, which is 5 square root 3. And square root 3 times itself, that's the same as square root 3 squared. And what happens if I have an exponent of 2 and a root of 2? They cancel. So what's left is 3. Okay, so this is 5 rad 3 over 3. Okay, short leg to hypotenuse. Multiply by 2. So 5 rad 3 over 3 times 2 becomes, so everybody think ahead. What does that 2 multiply by? The inside 3 or the outside 5? So this becomes 10 rad 3 over 2. Outside number with outside number. Okay. That is the exact same problem. Okay, let's do number 6. Okay, short leg, long leg, and hypotenuse. How do I go from short leg to long leg? Multiply by rad 3. I like it when we're given the short leg. How do I go from short leg to hypotenuse? Multiply by 2. Okay, these problems would be great to make flashcards of, so that you're really fast. 7 is the same. I think we're good. Yeah, we get the point. So we're gonna cross those off. We can do them later if you want. Okay, amplitude and period, and then we're gonna sketch a graph. So number 10, the amplitude is 3. The period is 3. By the way, using degrees, not radians. Okay, we couldn't graph it because this graph is set up for degrees. The period is 360 divided by B. Okay, so we need to know what B is? Yeah? What is B? It's not 4, is it? That 4 is on the bottom. Does everyone see that B is 1/4? Okay, so the period is 360 divided by 1/4. Keep, change, flip. The period is huge. The period is 1,440 degrees. Okay, let's make a little table. Theta and Y. Okay, so it begins at 0 and it ends, oh, yeah. It ends at 1,440. Yeah, see what I did with the period? Now, in future math classes, there might be a horizontal shift. We're not doing horizontal shift. Okay, so it begins at 0 and ends at the end of the period. Now I need the middle. Yeah, so let's take 1,440 divided by 2. And what is the middle? $720. Okay, cut that in half again and find the quarter, right? The middle of the middle is the quarter. Thank you, 360. Now figure out what that one's gonna be. All right, we're gonna take 360 plus 720. Thank you, 1080. Okay, see how the period determined my table. So one cycle is gonna end right there. Oh, you know what? Let's do the parent graph. Has anyone seen the old movie Karate Kid? Oh, you guys gotta watch Karate Kid. Okay, I'll demonstrate. Part of his karate, he goes like this. He's like, okay. Sorry for viewers at home. Now, watch Karate Kid and think, cosine curve. Like you're watching it with your family and you're like, look, he looks like a cosine curve in your family. You'll think you are weird. But cosine curve starts high, goes down, ends high, like your arms are up. Okay, or it kind of looks like a deer or something with eyes and a nose. Anyway, now what are we going to do with these values? We're going to plug in cosine. No, sorry. We're going to plug in 3 cosine starting with 0 divided by 4. Okay, plug that into the calculator. 3 cosine 0 divided by 4, close the parentheses, and what do you get? 3. Now we're going to plug in 3 cosine 360 divided by 4. So I'm just going to arrow up, arrow over, 360 divided by 4. What did you get? 0. Yeah, do it again. 720. I love the arrow up function. -3. Yeah, arrow up. 1080 divided by 4 is 0. And do we have a guess? How is cosine going to end? Anyone have a guess before we plugged it into the calculator? Yep. A lot of times these guys end the way they began. 3. Yeah, amplitude is 3. See how the amplitude comes in? So can you see the amplitude in the table? Right? Those 3s. And you can see, you don't see the 1/4, but you see the period in the table. So we start at 3, and then 360 is 0. 720 is -3. 1080 is 0. And there is 1 cycle of the cosine curve. Okay, number 11. So if we look at the parent, it's cosine again. Wow. Okay, the amplitude is 4. The period is 360 divided by B. And what is B? 2. So the period is 360 divided by 2, which is 180. Let's make a table. Notice that's not a 0, that is theta, Greek letter. So there is no horizontal shift. So we're going to start at 0 and we're going to end at theta equal to 180. Okay, the period is the length of one cycle. Okay, if 180 is the length of the cycle, what's the middle? 90. And what is the quarter mark? 45. 90 plus 45 is 135. Okay. So we are doing y is equal to 4 times cosine of 2 times the angle. So let's put in 0. And what do we get? 4. There's the amplitude right there. Okay, go up, type in 45. Zero. Okay, 90. -4. 135. This is starting to look familiar. 0. Look at the symmetry. Yeah, and what's 180 going to give us? 4. Okay. Do you ever see trigonometry in science? Yeah. You guys see trig, right? You do. You do see trig in science. 0 is 4. 90 is -4. Okay, 45 is like right there. 180 is +4. And 135 is right there. There is one cycle. You might see it more in physics, probably more in physics than chemistry. And it's looking a little cluttered. And it would continue, right? But I have carefully drawn the first cycle.
Yeah, because I was doing all the steps right, but then the calculator was giving me like decimals. So I was like,
Yes, we're going to talk about that. Okay, convert to radians. I know that, here's my unit circle. I know that this is 180 degrees, and 180 degrees is equal to how many pi radians? 1 pi, right? All the way around the circle is 2 pi. Halfway around. So 180 degrees is equivalent to pi radians. Okay, so to do a conversion, I'm either going to multiply by, so 180 and pi are the same. So 180 divided by pi would be like multiplying by 1. So we use fractions of 1 as unit converters, or pi over 180. Now think chemistry. If I have degrees on top and I want to cancel the degrees, then I need to use this one. Can you see how my degree units are canceling? And what's going to be left is the radians. We don't put a little r, but we could. Pi radians. Okay, calculator. So this is what you're going to do. You're going to do 2. Now, can I just cancel those zeros? Divide by 10. 24 ABC 18 equals. Okay, it's going to give you this. That is a mixed number. Now we're going to go second ABC equals, and I get the improper fraction. 4/3. So is the answer 4/3? So the answer is 4 pi over 3. Okay, so you guys do 35. This one is not going to become a mixed number because 135 is smaller than 180. Okay, so we're going to go 135 ABC 180, and we're going to get 3/4. Yeah, or we could also divide by 5, then divide by other things, and we could do it by hand. So the answer is 3 pi over 4. Yeah, not too bad. Okay. Now we're going radians to degrees. So what am I going to multiply by? You could do it that way, but how are we going to cancel the pi's? Okay, so we're going to choose either pi over 180 or 180 over pi. Okay, I have 1 vote coming into the chat. Which one am I going to use? I'm going to use 180 over pi. Not because we can easily see that we can cancel the pi's, because some books will throw in tricky problems with a pi. It doesn't have a pi, it just has like a 5. But we know we're canceling the radians. So pi cancels. Oh, easy peasy. 180 divided by 2 is 90 degrees. The radians got canceled I'm left with the degrees. Thank you. Okay. Yeah, do this one. So we're gonna go 180 on top, pi on the bottom, cancel the pi. Oh, I can tell. Can you do that one in your head? Look at the 18 and the 180. Yeah, can you reduce that one in your head? Or not? Use a calculator. What do we get?
170?
Yeah. Yeah, because the 18 cancels with the 180 and leaves 10 times 17 is 170 degrees.
Oh, I must have straight across.
Yeah, you could do that too. Okay. Now, these are a little harder. You don't say, right? You say cosecant. Okay. Cosecant is the reciprocal of so, okay, but it's not cosine. You would think cosecant goes with cosine. It does not, right? It's the reciprocal of sine. The cos do not go together. Cosecant goes with sine and secant goes with cosine. And I always forget where these all came from because I don't talk about it much. Okay, so we need to find sine and then flip it. So let's see, sine of theta is opposite. Oh, shoot. We don't have the opposite. Over hypotenuse. Okay, what are we going to do? We need this side right here. I have 2. I need a third, and I don't have the angle.
Oh, the ABC.
Okay, we're going to use Pythagorean theorem. X squared, and this is the hypotenuse, right? That goes alone. X squared plus 14 squared equals 7 rad 13 squared. Okay, calculator. X squared plus 196. Okay, now square 7 rad 13. So 7, you could do it in the calculator. You could change it to a decimal. This is actually, okay, someone help me out.
Anyone?
No. 7 rat, ding, ding. That's it. You got it. Okay, so you could either just plug it in and then square it, or you can go, oh, look, outside times outside, inside times inside. Can we see that rad 13 times rad 13? The radicals are going to cancel and the 13 is going to pop out. 49 times 13 is 637. Or you can just go 7 times rad 13 equals and then square it. You would also get 637. We're going to talk about this in a minute. Okay, what's next? Back to here. subtract 196. So x squared is equal to 441. Thank you. Take the square root. Look, here we are again. We keep seeing this. If I take the square root of something squared, the squared and the square root cancel, and the number pops out. And the square root of 441 is 21. Okay. So this is 21. So sine of theta is 21 over 7 rad 13, right? Opposite over hypotenuse. Talk about that later. Okay. So sine of theta is 21 over 7 rad 13. Here's a hint. Don't worry about the radical in the basement because I'm not interested in sine. I am interested in cosecant. So therefore, cosecant theta is the reciprocal. Yeah. So don't worry about the radical in the basement until we get to the end. Is there anything I can cancel? I can reduce. Okay, outside 7 with outside 21. So cosecant theta is rad 13 over 3. There we go. Nice. Okay, really quick. Let's go back to this. Do you see how the 7 and the 7 multiplied to get 49? Rad 13 canceled the rads and became 13. So how about this? Okay, so what's that going to be? Just a little extra practice. Good. Correct. 3 rad 5 and 3 rad 5. 3 times 3 is 9. The radicals disappear and we get 45. Yeah? Okay. Let's try this one. Secant theta is 1 over you can't put the cos together. Secant goes with cosine. Yeah. So, and that's going to be in your notes, right? Secant is the reciprocal of cosine. So let's find cosine theta. Is adjacent over hypotenuse. We do not have the adjacent leg. So what do we need to do? Pythagorean theorem. So we're going to call it x. Hypotenuse is alone. X squared plus 3 squared equals 5 squared. 3, 4, 5. Nice. This is actually a Pythagorean triple. Yeah. So x squared plus 9 equals 25. X squared equals 16. Take the square root. x equals 4, you may have recognized a Pythagorean triple of 3, 4, and 5. If the hypotenuse is 5 and one of the legs is 3, the missing one will always be 4. So if you have some of these Pythagorean triples memorized, you're going to be a happy camper. Okay. So cosine theta is, yeah, I'm right here. Cosine theta is adjacent over hypotenuse. Yay, I love a problem with no radicals in it. Okay, so secant theta is the reciprocal. Yeah, we're getting the hang of it. Okay, one more. This of this type. Now, sometimes you have what you need and you don't always have to do Pythagorean theorem. Okay, cotangent is exactly what you expect it to be. Is the reciprocal of, yeah, finally one that makes sense. The others are the opposite. Okay, I'm gonna just get it right. The others are the opposite of what you're expecting. Yep. Okay. Tangent theta is opposite over adjacent. Oh, we're gonna have to do Pythagorean theorem. X squared plus 21 squared is equal to 7 rad 10 squared. X squared plus 441. Okay. So can you guys do this on the calculator, please, or in your head? Wait, what?
Oh, it's 21.
Yeah.
It was 12.
Yes, but good because sometimes my brain flips numbers. Okay, can you see that this is 7 rad 10 times 7 rad 10? 7 times 7 is 49. The radicals cancel, the 10 comes out. 490. Okay, subtract 441. X squared is 49. It's funny. I can square radicals in my head. I can't subtract when it involves borrowing in my head. Okay, take the square root, and squared cancel, x equals 7. Okay. Tangent of theta is opposite over adjacent. Cotangent of theta is the reciprocal. Which equals 3. Done. Notice we have the reciprocal function, cotangent, cosecant, secant, and we have, not to be confused with the inverse functions. Yeah, which is how you work backwards to solve the equation. Okay, now that's it for the trig. Let's practice solving an equation by clearing the fraction using the clear the fraction method. The least common denominator of this equation is, you can either type it in or show me on your hands. Denominator. All right. The least common denominator is 4, but we multiply by 11. So least common denominator, multiply by all the tops. Same to the left as we do to the right. Okay, what's next? Or I'm just gonna say cancel. Yeah. 4 on top, 4 on the bottom. 4 on top, 4 on the bottom. Okay, now bring down the equation. 11 is equal to 7v plus 3v. Yes, you could have combined those earlier, but we are practicing the clear the denominator method. Next up, combine like terms. 11 is equal to 10v. And the last step is divide. V is equal to 11 tenths. Yeah, clear the denominator method. Okay, the next one's a little more tricky. Yikes. Okay, least common denominator of 12, 3, 2, and 4. What will bust a 12, bust a 3, correct? Bust a 2 and bust a 4. 12. Yeah, because 3 times 4 is 12, 2 times 6 is 12, 4 times 4, 4 times 3 is 12. Okay, 12 is the least common denominator. Multiply it by all tops of all terms. Okay, for now, we're either going to say divide or cancel. It's kind of, we could kind of describe it as divide. So those cancel, right? Okay. Now focus on those. We're actually dividing. 12 divided by 3 leaves 4. 12 divided by 2 leaves 6. 12 divided by 4 leaves 3. Okay, everyone write the resulting equation. Oh, yeah. $49 is equal to 32n plus 30 minus 21. Thank you. Now, okay, no comment. Why do we keep practicing these? Because people keep photomathing them. Don't avoid. I'm preaching to the crowd, okay? But we're gonna push through and we're gonna keep practicing. What's the next step? Combine like terms. 49 is equal to 32n plus 9. Okay, now we're picking up speed. Minus 9. 40 is equal to 32n. Divide by 32. Let's practice having the calculator reduce that fraction for us. 40, ABC 32. Uh-oh, mixed number. Second, ABC equals. So we get 5/4. And you're thinking, I would rather just divide by 8, but we're practicing with the calculator. Okay, now for maybe the hardest thing we've done all year. People hate these. Okay, add these expressions. Oh, how funny. Okay, just trying a new pen. Okay, let's get rid of this 21. So I need to multiply the top and the bottom. This is not an equation. We don't do left and right. We multiply top and the bottom by what? Yep. M plus 6. Okay, on the left. Multiply the top and the bottom by? Okay, that gives me a denominator of M plus 2, M plus 6. We're going to leave that in factored form. Okay, 5M plus 2 and 2M plus 6. Distribute 5M plus 10 plus 2M plus 12. And combine like terms. Whoops. 7M plus 22. M plus 2, M plus 6. Okay, for some reason, people really hate those. But it's kind of just a lot of steps. And guess what? It's showing up again on the week 16 exam. So let's do 22. Can you work ahead of me? And we'll see if we agree. Okay, does yours look like mine so far? Gives me a denominator of n minus 5, n plus 2. I'm just going to go ahead and distribute now because I'm just lazy. 4n minus 20 plus 2n squared plus 4. Do I have a mistake? Check your work with mine and see if I made any mistakes. Ah, I missed an n right here, huh? Okay. Okay, let's clean it up. Let's combine like terms and put it in order. I wonder if I could factor that. Now, you could leave it like this. You could factor out that 2. Now, you could leave it like this. Let's just check. Are there 2 numbers that multiply to get -10 and add to get 4? Two and 5? Nah, I don't think it's factorable. So you could either leave it this or this. Either one's fine. Yeah, there's nothing. So either one of those answers is correct. You could, some people multiply that out, but you better not make a mistake. You could just leave it like this and not risk making a mistake. That is it. Yes, todo. Yeah, we are winding down. This year is going to end quickly.
I already finished English too.
Yay. Okay.